Hey there, everybody, and welcome to the Daily Space Weather Show. We've got a ton of plasma filaments, a slight uptick in solar activity, a higher propensity for solar flares, especially on the western limb, and lots more to talk about. We'll tell you all about what's going on, the weather all the way from ground level, out to space, at least out to the closest star, and perhaps even beyond. And by the way, thanks for tuning into the Smash News Network, least busted name in news. We've got an incredible number of plasma filaments here on the Earth-facing portion of the solar disk. They are straight up draped across the sun here like garland. No, not that garland. That kind of garland, like you'd put on your Christmas tree. We also do have at least one new sunspot that recently rose in the eastern limb. Also, this sunspot group up here has shown some considerable growth in the past 24 hours, which is the time frame depicted on these HelioViewer movies. This is 24 hours of ionized helium from the Solar Dynamics Observatory. Here's one of the huge filaments that's just moved past the Earth strike zone, as the one behind it moves into the Earth strike zone. Either of those could become earthly directed coronal mass ejections basically at any moment, although we do certainly see some instability in the plasma filaments that are occurring over around the western limb. Here's a quick view of the south. There are filaments down there as well, folks. You can see one of them southwest, which would be down and to the right from the Earth scale image. And our regular viewers won't be surprised to realize that there is a prominence up there at the northern hemisphere as well. Here's this plasma instability I was talking about. This is the most likely place for a solar flare. We'll talk more about that momentarily. And let's switch to our SDO intensity gram. So there's yesterday plus today. Just to reiterate, this sunspot up here has indeed grown quite a bit, and a new group has formed as well to its southwest. So that's another new group there. The rest of these are pretty stable. Oh, it looks like a new group formed and then evaporated down here as well. That was a short-lived sunspot group there. And again, one more did rise very close to the equator, almost right on the equator there. Here's colorized magnetogram for that same time frame. Yesterday plus today, August 13th and August 14th to date. You know, folks, one of the challenges of making these videos is that by the time we put up the content, it's already obsolete because, of course, nature doesn't wait for us to upload. That's one of the reasons why we appreciate the live stream format the best. And let's take a look at volcanoes. So a paroxysm did occur at Etna overnight. You can see some explosions there and some lava raining down on the summit slopes. Let's see what else is erupting here at volcanodiscovery.com. So, again, the list starts out with Etna, as ballistic lava bombs rain down around the Sicilian volcano. Klyuchevskoye there, creating new real estate on Kamchatka. If you are an investor in Russian real estate, I guess your investments are going down in value because there's now more real estate. Luitolo also exploding. No indication on the ash plume size there. Semeru producing a 15,000-foot plume of volcanic ash. It's a flight level 150. Popocatépetl not sure if it is erupting or not, although volcanic ash not seen in satellite or webcam. Sangay in Ecuador exploding, flight level 200. It's a 20,000-foot ash plume. 15,000-foot ash plume over Revenador in Ecuador. As it explodes, it's a flight level 150. Flight level 240 over both Sabancaya and Ubinas in Peru. Those are 24,000-foot plumes of volcanic ash as both Sabancaya and Ubinas explode. Next, we'll look at seismicity, and it has been very, very quiet as far as earthquakes over the past 24 hours. Seismic activity currently low, and we're a little bit overdue for a 7-magnitude earthquake. 0 quakes of a 5 magnitude or greater for the past 24 hours. So like CNN often reports, the news story is that there is no news. Remember when that plane went missing and they reported for days and days and weeks about how, hey, the news is that there's no news. And let's get back to space. It is where it's at, as far as I am concerned. Here's a 24-hour video from SDO and 171 angstroms. You may see a simultaneous event happening down at this group down here, this active region here, and this region up here. Two separate events occurring at the same time, perhaps connected in some way, as they often are. Another indication that the sun has a real surface, and perhaps its interior is not indeed made of gaseous plasma. So that's the eastern limb. Again, we've got at least one new sunspot group since yesterday's video that rose right around the equator. Here's the equatorial view as we move from east to west. And that Mike Smith filament there just above the Earth scale, so dense that it indeed shows up in 171 angstroms. And there's that western limb. Let me say it again. The most likely place for a major solar flare is by far this area right up here. So we are seeing plasma instability on the GOES 16 as we produce the video. That area far more likely to produce large solar flares than any place else at the moment. Moving right along to some more space weather stats. The 10.7 centimeter radio flux, now up to 150 solar flux units, following a significant downtick in solar activity, both in sunspot number and the radio flux. There is a one-year graph of those both. The red line there is the sunspot number, the black line is the radio flux. And don't expect the lull in activity to continue. We are also seeing, as forecasted, an uptick in coronal holes. So we've really seen a shortage of coronal holes throughout this entire solar cycle. That will not continue forever. Space Weather Enthusiast dashboard not forecasting any sort of space weather storms or geomagnetic unrest or anything like that. Just keep in mind that there is a significant possibility of incoming coronal hole high-speed streams. So there are two coronal holes, which we'll get to here in a moment. Before we do any of that, let's take a look at Earth's magnetic moment from space. Here's magnetohydrodynamic pressure, modeled by the Space Weather Modeling Framework, out to about 12 Earth diameters. And of course, this is part of the reason why we joke around and say Earth is croissant-shaped, as all the funniest jokes are the jokes that are rooted in truth. Shout out to Seinfeld. It's funny because it's real. So that's the past 4 hours of Earth's magnetic moment from space. It is geomagnetically calm for all of you Earthlings out there at the moment. Here's Earth's magnetic moment from the ground. Again, it is the last 4 hours. This depicts magnetohydrodynamic pressure at the ground. Magnetic flux density, rather, at the ground level. And not a lot going on, but we are expecting an intensification in the next day or two. Probably something like 36 hours from now, from coronal hole high-speed streams. Planetary K-index at 1. Again, geomagnetically calm conditions. The planetary K-index, for you new viewers, is an average of global geomagnetism. Now, looking at the real-time solar wind, here's what you can expect. You can expect a significant uptick in the solar wind density, and as that drops, you can expect a significant uptick in the solar wind velocity. That is the telltale signature of a coronal hole high-speed stream at the moment. Nothing going on as far as solar wind parameters. Very calm there in the solar wind. And that means that we should get a very good signal when we do see some space weather coming in. Current conditions are solar wind speed about 344 kilometers per second. Solar wind density quite diffuse at about 2.25 protons per cubic centimeter. GOES magnetometers here are smooth. That's another thing you can expect to see. Get a bunch of variation happening in it when the coronal hole high-speed stream does arrive at planet Earth, as the plasma in the Earth system will be trying to reach static equilibrium. Next, how about a look at the top view ecliptic plane field plot? Here is the heliospheric current sheet depicted in polarity. Right now, Earth is in a South Pole current sheet. North Pole current sheet here is still several days out, maybe 3 or 4 days out. And let's move to our line of sight field plot. As we ramp up to solar maximum, people have been saying since January of 2023 that we were already at solar maximum. Soon after which, we saw the sunspot number go up over 200 and the radio flux go up over 200. So we're not there yet, folks. We're still like a year out from solar maximum. Mark my words. In fact, I guess these videos do mark my words. Let's move to coronal holes. And there is our line of sight coronal hole plot. So the current well-defined coronal holes that are on the Earth-facing portion of the solar disk are of South Pole orientation, it looks like, according to this imagery. And let's take a look at the SDO. So there's another 24-hour video from SDO, the Solar Dynamics Observatory, and 211 angstroms is a great wavelength to show coronal holes. Actually, I think this is actually a North Pole coronal hole. I mean, it looks like... Okay, let's bring this back. So these are south. And this one here is actually north. So anyway, that's another 24-hour video from SDO. Let's take a little closer look at those coronal holes. There's the northern one, still in the northern hemisphere, which means it's got a long way to go. Quite well defined there. 211 angstroms does show some great depth of the solar corona, the sun's atmosphere. Here's the southern coronal hole system. Those are South Pole orientation. And it's perfectly shaped there, just like an S for south. Sunspots are next. And let's see. So this group hasn't gotten a name yet. 3402 was named. So this one will be 3404. Actually, this one might be 3404. So let's see. 3404, 3405, and 3406. So 3 new sunspots likely to get named in the coming 24 to 36 hours. And once again, flare probability is by far the highest up there in the northwestern limb. Here comes some totally sweet SDO 24-hour videos. Here we've put together 131 angstroms, as well as the SDO magnetogram. At the end of that, you'll see a little bit of unsynchronized data there. That is because the magnetogram is not as up to date on HelioViewer as the 131 angstroms is. Here we've subtracted the 131 angstroms. And the most unstable group is this group up here. It has grown considerably in the past 48 hours. See yesterday and Saturday's daily space weather videos for details on that. We've conveniently placed them all in a playlist for the daily space weather show. Here's the SDO continuum. So these are the 3 new groups. This one right here, this one down here, and this one that just rose just north of the solar equator, it looks like. Which brings us to energetic particles and solar flares, which have been pretty mild here over the past 24 hours. Here's the ghost proton flux for the past 3 days, which has moved back down to a baseline level. Pretty unremarkable there. And the X-ray flux here, you can expect this to rise over the coming 24 hours. When we show you tomorrow's video, you'll see that I was correct, as we'll have a higher X-ray flux. It's now just below a below a C-class background flux at about B8.7. it'll probably move back into a C-class background flux overnight. Next, let's take a look at our favorite flare wavelengths. Here is 131 plus 94 angstroms. Those are both ionized iron. That is, once again, the Solar Dynamics Observatory. My favorite space telescope. And wait till you see the imagery from the James Webb. The James Webb is competing and doing a fine job. So that's the past 24 hours. Again, I would note that right over here, there was a simultaneous event that happened there. You can see pulses coming out of both of those areas pretty much at the same time. And that's a regular thing, folks. We see reverberations across the solar surface regularly when there are, especially when there are major events. So maybe something happened on the far side of the sun. Keep in mind, folks, we regularly see coronal mass ejections without solar flares and solar flares without coronal mass ejections. So they are separate phenomena. Don't get them confused. Solar flares are photons. Coronal mass ejections are primarily protons. Next, let's turn away from the sun for a moment, as it has just risen over the horizon here over Lehigh Valley, Pennsylvania. And let us know in the comments if you saw any Perseids, or especially if you took any time-lapse photography of Perseids. That is our star chart from skyandtelescope.org. If you want to make your own, just put in your location, click the Now button, and you'll have a current star chart for your situation as Saturn sets over in the southwest, and Jupiter near the apex of its trip across the ecliptic. And right up there is where you could have expected to see some meteorites, or meteors at least. I guess you won't see meteorites by looking up in the sky, right? Now, if you haven't seen our community posts, check those out, because we put out all kinds of shares, because, you know, we are endorsing certain videos on YouTube. So our community posts will show you some stuff that you might not see if you just look at our videos. So check out youtube.com/smashomash/community. And like yesterday, we put out one about Tyler Hamilton being red-pilled. Links to certain vitamin supplements. Videos with comedic value. And one of our viewers submitted a video featuring some Perseids. There's a great, very bright, long-lasting trail of plasma there, and you can even see a smoke trail there. Great video there. Go check it out yourself. You can find it again on our community posts. That was unintentional. Let's bring that back again. Great view of a meteor there passing through clouds and lighting up the sky. Speaking of lighting up the sky, let's do a solar system forecast. As we strive for completeness on our daily space weather videos, propaganda-free and fact-filled. So here's your one-week forecast for the solar system from theplanetstoday.com as we approach the August new moon. The night sky gets darker and darker. This is where things are today. There's where things will be in 1 week. Next, our astronomy picture of the day. And man, oh man, this one is a spectacular one. And this is why the James Webb is competing with the SDO as my favorite telescope, because this is, as I am a cosmologist, and the reason I do heliophysics is because heliophysics is cosmology. This is an insane image of a possibly planetary nebula. Check out all the filamentary structures in there. This thing is about 1 light year in diameter, as the central star is believed to be a sun-like star which is believed to be evolving into a white dwarf stage following this insane output. Huge nebula there emitted by that star. A very dense gaseous nebula there, known as, this is the Ring Nebula, otherwise known as M57 in the Messier catalog. Let's do another scroll through of that. Look at the detail of the James Webb Space Telescope. That is extremely the highest resolution imagery probably ever taken of the Ring Nebula in the infrared spectrum. What's great about the infrared spectrum is it's better at penetrating dust, which is why it shows so much detail. Look at all those filamentary features around there. That is an absolutely berserk image. Yowzers. How about them apples? All right, next let's look at coronagraphs. Here are yesterday's coronagraphs from George Mason University. We did have some CMEs that happened late in the day. Those coronal mass ejections do have the possibility to have some minor earthly directed components. They're not likely to show up until sometime after midday on August 17th. So those will be minor impacts as they are pretty diffuse, not major events, hence the term minor. That's 104 frames from yesterday at George Mason University. And starting out today, this is August 14th. To date, starting out the day with coronal mass ejections. So there's a forecast correctly done from yesterday. Now we're not going to show stereo A because it's looking like it's not really showing any relevant data at the moment, but we've got Soho, Lascaux, C2, and C3. So let's bring these back. We're going to bring them back to about 2 o'clock this morning. So around then you can see multiple things happening here. Let's bring this back even further to about 1900. So there you can see the first event coming out of the west, and then it looks like a second event coming out of the west, and then an event coming out of the southeast. So multiple events happening there late last night and early today. Soho Lascaux C3 confirms this. There could be a minor Earth-directed component there in that data. So we'll just bring these back and play them through for your viewing pleasure. Number 1, there's no reason to take a number 2 in your pants over this. So sit back, relax, and enjoy the light show. Engage. Now, as we said earlier, filaments are often responsible for these coronal mass ejection impacts, and there are indeed quite a lot. So it looks like one may have ejected from down here. Many of these filaments have names. This is the Donna Marie. This is the Kate Bush. Over here is the Mary Grace. This is the Mike Smith. And we've already got names picked out for some of these other filaments here. Oh, it looks like this one might have ejected. All right. Sweet. So that could be a stealthy ejection there. Anyway, that's the El Teide ground-based solar observatory, part of the National Solar Observatory. And we'll also show this in gray as it shows prominence, as one of these filaments is becoming a prominence, the Donna Marie up here. And let's take a look at filaments from the SDO. So here is another 24-hour SDO video. Here we've put together 304 plus 193 angstroms. And I don't know, this filament looks like it is still attached here, so that might have just been some erroneous data there from El Teide. Not sure on that one. It certainly looks like it's still intact to me. And here's a little closer view again. The Earth-facing portion of the solar disk draped with huge plasma filaments there, like garland. Before we get to our bonus features segment, here are the past couple of hours from the GOES 16 SUVi. Again, you can see instability happening over here in the northwestern limb, exactly as forecast. And yes, indeed, folks, you too can forecast solar flares. So that's the current state of affairs. Again, that lasts about 2.5 hours. Let's move to bonus features. First, satellite charging hazards, and we don't have any. It's smooth sailing. No high-energy electrons building up inside of satellites, and no low-energy electrons building up outside of satellites. The GOES electron flux here remains in a fairly standard range, right around warning levels there, not significant. There's the one-year graph to put the electron flux in context. Moderate to high levels here at the moment. There is the relativistic forecast model. And it looks like NOAA agrees here that there is a coronal hole high-speed stream coming. We may see these get even lower. It all depends on the intensity of that coronal hole high-speed stream. Look for that density uptick followed by a density downtick and a velocity uptick that we described earlier in the video. The electron flux is measured at the F layer of the ionosphere. Feel free to pause the video on this frame. If you're not familiar with these distances in kilometers, chemical concentrations, thermosphere temperatures, and electromagnetic radiation penetration into Earth's atmospheric layers. Here's one slice, the F layer, and its vibrational frequency megahertz, which are millions of vibrations per second. We are seeing some high-frequency anomalies here. Don't worry if it's all Greek. Don't worry if it's all Cyrillic. Don't worry if it's Egyptian hieroglyphs that you also can't read, like cuneiform. We'll show the anomalygram, which should clear it up. There's the anomaly in megahertz from the 30-day median. So you'll see quite a bit of blue on this. Those are high-frequency anomalies. The red is low-frequency anomalies. There's the latest image. That's 11:15 Universal Time. Total electron content. We'll show you where GPS errors are likely to happen. Signal refraction will cause GPS errors. That is caused by free electrons in between your GPS satellite and your handset. Feel free to pause the video on this frame if you're not familiar with distances in miles. And there's the total electron content forecast. And we'd love to show you the North American total electron content forecast. Unfortunately, there is some missing data there, it looks like, so we'll skip that and move to the latest intensitygram and latest SDO magnetogram. So, oh, check it out, a new active region rising up here high in the northern hemisphere. Another indication that we are not yet at solar maximum. I don't care who told you we're at solar maximum. We just simply aren't. We're like a year out. Here's a new sunspot group as well, so we may have as many as 4 new named sunspot groups in the coming 24 hours. And before we get to meteorology, take a moment to press like and subscribe. Take a moment to visit the links in the description below this video. If you enjoy these videos and prefer to see them remain existent, publicly visible, and free for all to view, maybe pick up some merch. Give Smash staff a raise. Don't be an imbecile. Let's bring back old-timey terms. Anything else would be hogwash. So don't be an imbecile. Imbecile, yeah, it's also an adjective. In other words, you could have three imbeciles in the same sentence. Don't be an imbecile, imbecile, comma, imbecile. See what I did there? I overused a term. And I'm sure as you are viewing this video on YouTube, you've probably conversed with many imbeciles. Keep in mind that you should definitely love people that you dislike. However, as hard as that might be, they may still be imbeciles. They may be incurable. Again, check out our community posts if you haven't. Press the like button. Press the subscribe button. Did you know that our video thumbnails contain more information than entire channels? Yeah, entire channels put out disinformation, fraud, propaganda, and nonsense. And remember, folks, the line between misinformation and fraud is simply intent. Fraud is just intentionally misrepresenting material facts. You can also shop via our Hemp Lucid shop, which you can find in the description below this video, as well as on our homepage at smashomash.com. Smashomash.com is simply the best. You can also find links to the Amazon shop below this video and on smashomash.com. Maybe pick up some spaceware. Yeah, spaceware. What do you wear in space? Let us know in the comments. You got chrome pants? Do you have a chrome shirt? Do you have a chrome bucket hat? Do you have solar shades? And best of all, we've created our own subscription services site. It's called smashomash.com/SmashTeam. And if you want additional content, highly recommend that you check out smashomash.com/SmashTeam. We're going to put up a post today about my crap theory. Yeah, my crap theory, CRAPF. The only plausible mechanism that I can figure out explaining the solar sunspot cycles, derived from a combination of inductive and deductive reasoning. My theory is crap. CRAPF. Gold Smash Team members will get to see that. However, the rest of you can forget it. Until, of course, we submit the paper for peer review. At that point, everybody will get to see it. It'll get published somewhere. I guarantee it. I guarantee it that you'll fairly soon get to see it. Smashomash.com/SmashTeam. There's also a gold annual paid up subscription, a silver, and a bronze level, which will cost you $0 per month. And let's go wave chasing. Yeah, wave chasing. I'm a wave chaser. What about you? Here at the Smash News Network, least busted name in news, we help seafarers and skyfarers alike. There are the world's largest waves, and the oceans are actually kind of calm here at the moment. I mean, when the largest waves are only less than 32 feet, that's not too bad. That is in the East Central Pacific, by the way. In a very desolate portion of the ocean there, somewhere in between the Galapagos and Hawaii. This map depicts surface winds and significant wave height. Even the Southern Ocean is pretty calm here at the moment. There is some good surf at Japan, however. So those are the second largest waves in the world. Nearly 30-footers there. So if you are a trans-world surfer, that is a good place to visit your favorite break. All right. So let's move to meteorology here. These are the surface winds of the east. These are the jet streams of the east. These are the jet streams of the west. Like sands through the hourglass of time, these are the jet streams of your lives. Here are the surface winds. Surface winds of the central world. And the jet streams of Europe, Africa, and the Middle East. Next, global boiling update. It's a global boiling update, folks. You probably want to know what part of the globe is boiling, and the answer is no part. However, the hottest water in the world is in the Persian Gulf at like 94 degrees Fahrenheit. That's pretty warm. And we've put out a tweet. We've posted on X because we'd like an alert from the UN Secretary General. We'd like an alert when that reaches 212 degrees Fahrenheit, the boiling point of water. Almost halfway there at 94 degrees. Windy.com will show you sea surface temperatures. And here is clouds and fog over the Americas. As we get closer and closer to Earth weather for the lower 48, here is the full 50-state weather.gov map, complete with alerts and keys shown. The Gulf states are expected to be hot, along with the Pacific Northwest, and some flooding coming, especially around the Great Lakes region. I'm not so sure about Missouri and Illinois there, but let's take a look at some forecasts. First, we'll show the total accumulated precipitation in inches. So there you go. There's the GFS 72-hour total accumulated precipitation forecast in inches. Heaviest rains will be coming to Michigan. So east of Lake Michigan. Expecting over 5 inches of rain. That's a lot of rain. And then a band of heavy rains there going from Missouri, Illinois, Indiana, Ohio through Pennsylvania and into New York. 72-hour GFS total accumulated precipitation forecast in inches. GFS 72-hour pressure and precipitation forecast. GFS jet stream forecast depicting 250 millibar winds. And the GFS temperature anomaly forecast in degrees Celsius. So running out of time here for the hottest weather, as the hottest weeks of the year are the last 2 weeks of July and the first 2 weeks of August. So you've almost survived the global boiling. Pardon my sarcasm. And let's move on to our lightning mapper. There's the past about 10 hours. Some significant lightning here moving from Texas into Oklahoma, Arkansas, and Missouri. Now crossing Kentucky and Tennessee. Here's a real-time lightning map courtesy of lightningmaps.org, which could save your hide from being tanned with Lichtenberg patterns. Don't get struck by lightning, folks. Most human lightning strikes are fatal, even though they are not usually direct strikes. Direct strikes will carve a lightsaber-like hole through you. So there's the storm front there, just north of Bowling Green. Once again, if you enjoy the content, press like, subscribe, and share. As these videos have been, shall we say, less than popular. We're not even at 4,000 subscribers, having done daily space weather videos for over 6 years. So help us out on social media. Somehow it seems like organizations like Alphabet, Apple, Meta, and Twitter are not really being particularly helpful recommending the content. Probably too many facts, which is part of the reason why we launched SmashoMash.com. And welcome to the Neo Renaissance. Congratulations on realizing the channel exists. We remain surprised. Links and additional content like the Smasho forum. We built a huge web ring for people like you. And here is that storm front. Some significant weather there. About to hit Charleston and so on. Also Cincinnati. There's a brief look at the full 50 states as precipitation looks like it's subsiding at Alaska. Here's the lower 48. As heavy rains are about to cross Lake Michigan. Did you know the Great Lakes Triangle is actually deadlier than the Bermuda Triangle? A lot deadlier. Because there is so much shipping going on through the Great Lakes. And look, folks, here's a great spot where people will think that it's a chemtrail. Check it out. Oh my God, it's a chemtrail. It's a chemtrail, folks. Look, it must be cloud seeding over, just a line of like 1,000 miles. I'm sure it's cloud seeding, right? Even though the resolution of this map is 1 kilometer if you zoom all the way in. Here's why it's actually happening. Because a bunch of cold air is coming down from Canada and running into this high pressure air mass right here and creating a huge pressure gradient, causing clouds to suddenly form as the Earth's atmosphere attempts to reach static equilibrium. Also compression happening over here as this relative low is compressed in between this relative high pressure and pressed down by this relative high pressure zone. Anyway, here's your recap. U.S. Doppler radar for the lower 48. It depicts vertical motion in the air column. The space-based shortwave radiation map, which shows clouds and fog, even at nighttime. And the water vapor map, which clears things up when it's not so obvious what is causing your weather. It works great in the winter. It works great in the summer. It leaves no stone unturned. Anyway, thanks for tuning into the Smash News Network, least busted name of news. We remain surprised that you found it. Congratulations on realizing it exists. I'm headed back to the bunker, but in the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. I'm going back to the bunker again. What?